kind of fun. Hi. So our goal today is the first lesson in our new unit, and it is understanding ratios.
You should be copying down the definition in your notes. A ratio is just comparing two numbers using division. There are several ways that you can write ratios, so we have some samples here. You could use the word to. You can use a colon. You can use a phrase out of. And of course, with our division, you can use the division bar.
When writing ratios as a fraction, you always want to make sure that you write them in simplified form. So let's take a look at the notes that we have for you. Again, when you write them in fraction format, when you're comparing two numbers, let's say we would say that in a room for every 2 boys, there were 3 girls. The first number would be your numerator. Your second number would be your denominator.
Sometimes your units may not be the same. Now, if we had boys and girls, those are people, that's the same unit. However, you might have inches and feet. They're both measuring length, but the units are different. You have to have them in the same unit to be considered simplest form. We are going to change to the smaller unit. So inches, feet, inches is smaller. We change both of them so they're inches.
When you write a ratio as a fraction, if you're changing the units and you're changing them, say, from feet to inches so that they're both inches, you want to make sure that you divide by a common factor so they're in simplest form. So for example, if I would say I have 2 feet compared to
8 feet.
Oh, all right, you took it a little different step. 8, well, should I use inches?
Sure.
All right, and I want them both in inches, then because this is 8 and I've got 2 feet, I know that there's 12 inches in 1 foot, so I have 24 inches. Notice that my first number would be 24. My second number would be 8. They're both inches, but notice that I need to divide by a common factor. In this case, the greatest common factor would be 8, which would get me to 3 to 1.
Which brings us to our last step, which is you always have to write 2 numbers for a ratio, because remember the definition, we're comparing 2 numbers. So even if the denominator is 1, you need to leave the denominator there. We are not going to write it as 14, which is the same as the sample Mrs. Armentrout has, where she left it 3 to 1.
So we're going to take a look at some examples, which of course we want you to make sure that you are writing down in your notes. We have first 12 goldfish out of 30 fish. So since a ratio is comparing 2 numbers using division, remember that there is a bunch of different ways that I can show that. Here we even see the phrase. So I could say 12 to 30. I could say 12 out of 30. I could use the fraction bar, which is the most common way that we're going to be writing our ratios, so that we can make sure that we always simplify. Because I have 12 out of 30, I can divide by a common factor. Now we always say, if you can't think of anything, if they're both even, start with 2. But I happen to know that 6 would go into both of these. So I'm going to divide each by 6, which is going to give me 2 to 5, or 2 out of 5.
In the next example, I have 15 to 9. Here we have one of our phrases again. Let us know we have a ratio. Sometimes we won't have units on the numbers. I'm going to first write it in my fraction form. The first number is our numerator, second is the denominator. And then I'm going to look and see, 15 and 9, what's a factor they both have in common? Well, I know the factors of 15 are 1, 15, 3, and 5. And out of those, 3 is also a factor of 9. So I'm going to divide by 3. I will have 5, 2, 3. Notice we normally would call this an improper fraction, and if it was a fraction we would, that we're going to be doing some work with, we would normally change it to a mixed number. However, if we want to compare two numbers, we have to leave it in this form and not change it into a mixed number.
In our last example, we have 2 minutes compared to 75 seconds. Notice here we have the colon as an example of comparison. Again, we're going to write this using the division bar, but notice that we have minutes compared to seconds. Those are different units of measure. As you know, 1 minute is not the same as 1 second. So we have to make these the same unit of measure. Again, we're going to go with the smallest unit of measure. So we're going to use seconds. And since the second number is already in seconds, I can plug that in right away.
Now I have to use my background knowledge and think how many seconds are in a minute. And I know there's 60 seconds in a minute. Since I have 2 minutes, that's 60 seconds plus 60 seconds, or 120.
Again, the reason this says 120 is because we multiplied 2 times 60 so that they would both be in seconds. So now we have an even playing field. We're comparing seconds to seconds. You will notice that both of these end in a 0 or a 5, so I know that these are divisible by 5. So if I divide these by 5, let's see, 120 divided by 5 is 24.
24.
All right.
I'm thinking in 100 I know there's 20, and in 20 I know there's 4, so 24.
Perfect. And 5 divided by 75, let's see, is that 15? Awesome. Now, I notice that I'm thinking that both of these share another common factor. So I have to keep going until they share no common factors. Both of these share the common factor of 3. So 24 divided by 3 is 8. 15 divided by 3 is 5. So we have an 8 to 5 ratio. For every 8 seconds in my first number, there are 5 seconds for my second number.
We're going to be looking at some ratios that have what we call a complex fraction. Now remember, complex fractions are when we have a fraction, a division bar, and a second fraction. So for example, in this first problem, we have 4 2/3 yards out of 2 feet. So looking at this problem, we want to first make sure we have our units the same. Now in this problem we don't have the same units. We have a yard and we have a foot. So I'm thinking a yard or a foot, that's like a ruler, and my yard, that's a yardstick. So I'm thinking there's 3 rulers in a yardstick. So I'm going to have to change these both now to feet.
How are you going to do that?
Alright, so what I am going to do is, looking at this, for each yard there's going to be 3 feet. So I'm going to have to multiply.
All right, so if we have 4 2/3 and we are multiplying by 3, remember our rules for multiplying fractions and mixed number? You need to have everything as a fraction first. So I'm going to do what I call Mac Daddy, and that means we're going to multiply, add, and copy. So 3 times 4 is 12, plus 2 is 14. And then I'm going to copy it over the 3 times. We know that taking a whole number is easy. We just put that over a 1. I can cross simplify because I have these 3's here. If I divide them both by 3, I'm left with a 1 there and a 1 there, which simply means that I am going to be left with 14.
So I'm going to rewrite here 14 feet out of 2 feet.
Since we want to get used to writing our ratios with that division bar. We're going to rewrite with the first number on the top and the second number on the bottom. And then we're going to put this in simplest form. Both of these can be divided by 2. Now remember, 14 divided by 2 is 7. 2 divided by 2 is 1. Normally we would rewrite that as 7, but not this time because a ratio compares 2 numbers. And so we need to see both of those.
In our next problem, we have 3/8 cups of sugar to 3/5 cup of flour. Now, if we write this in fraction form, maybe Mrs. Armentrout can write it right here if there's a little more space.
I can. Let me just point out, you might be looking at sugar and flour. That's not a different unit of measure because we're measuring both of these in cups. And so we don't have to change these at all. But now, you want me to write it over here?
Yep, write our complex fraction. All right, so we have fractions within a fraction. That's why it's called a complex fraction. Now, in order to work with this problem, when you have complex fractions, you are going to be multiplying by a reciprocal here. So, for example, down on the bottom we have 3/5. The reciprocal is going to be 5/3. So multiply both of these by 5/3.
Now, multiplying both of these by 5/3 does not change the value of this complex fraction. Because if we have 5/3 over 5/3, you know that when the numerator and the denominator are the same, it equals 1. So basically, we're just multiplying this by a form of 1, which is why it stays the same value. All right, so let's take a look at what's going to happen here.
On the bottom, notice that the 5's will cancel, 3's will cancel, and we're left with 1. So now we're just going to work on our top numbers.
All right, so over here we have 1, and with our top numbers, I've got a little cancel opportunity here. So I've got a 1 and a 1. 1 times 5 is 5, and 8 times 1 is 8.
Now, any number over or divided by 1, we know is just that number. So we are left with 5 to 8.
The reason that we don't have to write this one here is because when we divide 5/8 by 1, we are still left with 2 numbers, which is what you need to have a ratio.